So in this tutorial, we are just going to see about how can we apply a priori algorithm using the R Studio and over the data Titanic.row data. I have got this data. Okay, I'm just loading this particular data. Okay, I have written all the comments here so that it is easier for me to run. Okay, so I have selected that. I'm loading the data, the Titanic.row data. This we have already seen in RapidMiner. Okay, so this data we are going to download. So we will see how the data will look like. So control enter. So you have to just load. Okay, I'm just loading it from the R data mining trial. So that is where I have this data is Titanic raw data. You could see it here. Okay, and I'm doing control enter. So it is loaded from this particular folder. That is what is. Now we have already seen this command str of Titanic.row. So this will basically gives you the structure of the data. So if you could see, we have already seen that it is a data frame. So the data type is data frame. So that means, it can have different type of data types there. And then it has got 2201 objects with 4 variables. So these are the 4 variables. So class, sex, age and survived. These are the different type of variables it attributes or parameters it has got. And each of the parameter has got 2201 instances. So that is what is basically the structure of the Titanic.row. Now we are going to do the association rule mining, and in that we are going to find out the arules, association rules. So we need to find out the association rules. So if we are simply applying, so there are so many libraries which are available in RStudio. So in that this arules has got its own it's kind of the default one, the association rules. So it is a library, okay, which is there in RStudio. So when we just do that, we are getting an error. The error which we get is that the error in library rules and there is no package. So we should understand that we need to first install the package arules. Okay, so we need to first install the package arules in order to use it. So for that we can go to the install packages and we can use arules. So it comes as arules. Okay, and we can install that. So now our tool is required. Okay, fine. So it has told so many things and it is basically installed. So the package arules unpacked and it is successfully unpacked and it is now ready for us to use. Now if we again click on that, okay, and when we do the control enter, so now you could see loading required package matrix, okay, attaching the arules, the following objects are masked. So all this information. So we have this library of arules now. Now we are going to find the association rules which are there by default with the default settings. We are not giving any conditions or anything, right? By default, what all are the rules which are there? The a priori. So we are applying the a priori algorithm, okay, upon the Titanic data. So when you click on the a priori, okay, when you hover over this a priori, once again, when you hover over this, it's coming. Oh yeah, this one, you could see this is the algorithm which will help you to find out the association rules. So when you look over to the association rule mining, you know that there are 2 steps. So this is, I'm talking about the generic association, the algorithm for association rule mining. The first one is nothing but finding the frequent item sets. Second one is nothing but generating the strong association rules from the item sets which has been generated, right? So you should understand this a priori algorithm and FP growth algorithm, that is frequent pattern algorithms, are 2 algorithms which help the association rule mining task to find the frequent item sets. So that is where we use a priori algorithm. Okay, so here when we see here, you could see a priori data parameter equal to null. So its corresponding parameters will be displayed there. Okay, so now we are going to run this. So understand, if we are using a priori upon Titanic.row, we are going to get some rules. Okay, we are going to get some frequent item sets. So we are going to generate the rules by that. Okay, so you could see here when we run that particular thing, you could see that. So these are the parameters. So we have taken a confidence of 0.8, the minimum value, the maximum, right? All this information has been given, and the minimum support count is 220. So item set preferences, so sorting and the recording items. So there are so many things which has happened. Now still the rules has not been displayed. So in order to display the rules, we have something called inspect rules. Okay, we have inspect rules. So you could see there are so many rules which has been displayed. So you could see that in the Titanic data set. Okay, in the Titanic data set, okay, these are the general or the common rules which you could see by using the a priori. Okay, so when class equal to second, okay, there is a common chance that adult age is adult. Okay, and what is a support, what is a confidence, so everything has been given to you, and even the support count, the lift. So it has been done basically. So the rules has been done basically upon three different conditions. Okay, so this is the strong rules which they have actually identified. Okay, these are the strong rules which has been identified. Okay, and in this strong rules, so you could see here in the previous step, you could see 27 strong rules has been identified. Okay, so here if you see, you could see 27 strong rules has been identified. Okay, so by using the a priori algorithm, okay, and by generating the generating the frequent item sets, and by understanding the strong rules by three conditions: support, confidence, and coverage. So coverage we have not learnt, don't worry about it now, and lift. Okay, so all these things, so support, coverage, and support, confidence, and lift we have learnt. Okay, support should be greater than minimum support count, and confidence should be greater than minimum confidence count, and lift should be greater than 1, right? So you could see all the rules which confines to that is appeared here in this particular example. Okay, so this is what you could see here in the, so these are the rules which has been selected. Okay, these are the rules which has been selected. So you could understand that when the class is equal to third, sex is equal to male, and survived equal to no, okay, it is a higher chance that that his age is adult. So he is of adult age. So this is one rule which is frequently seen. So like that we have actually understood with the basic A rules. So this is one library which is there in the R tool. Now what is the other one? So now we are just trying to set the RHS. Okay, so this is the LHS part. Now we set the RHS. That means that say we have survived equal to no and survived equal to S in appearance to make sure that only survived equal to no and survived equal to S will appear in the RHS. So we are just trying to come out with some constraints, or say I want to know only the rules which is confined to survived equal to no or survived equal to S. So such kind of, that means in the RHS part, this is the RHS part. So in the RHS part, I don't want age, about any information about age, sex and all. I just want the information specifically about the survived people, or maybe not survived people. So how can I do that? So here is the algorithm. So this a priori, as I told you, there are so many parameters. So you are taking the data set. So this is the data set, right? So this is the simplest one which we have seen here in the previous one. Now you are giving more parameters to it. So the parameter equal to list, and the minimum length should be 2, support, confidence, the appearance. So you are specifically giving the labels, what all the labels which has to be there, and then you are also giving the default RLHS, and this you don't worry about it right now. So it is about the verbose, which has to be printed, which don't has to be, which has not been, has to be printed. So that's all about it. So this line you are going to run now. Okay, so control enter. So when you control enter, yeah, so it is done. It is actually, it is blue in color, it is not red in color. So it is now, you are sorting the rules by lift value. Okay, you are sorting the rules by lift value. Okay, so that is also done. Now you are going to print it. Okay, so now you could see, so all the lift values which are greater than 1 only has been displayed. So I don't know whether you have noticed here. So here you have not sorted by lift. So all the values, 27 rules has been displayed. So in that you could see certain rules which is almost 0.9, all such rules has also been displayed. But here we have actually confined to, we have applied certain conditions or certain constraints. What are the constraints which we have concerned? We have applied that the RHS part has to be either survived yes or no. Okay, and we want to sort the data in such a way that the lift value has to be sorted by lift. So the lift value has to be 1 or above. Okay, and the LHS could be anything, right? So that's all. So this is what the rules which we have applied here. Yes, and the minimum length has to be, okay, minimum length has to be 2, the support count has to be 0.005. So you could see all the values are greater than 0.005. The confidence value has to be 0.8 and above. So you could see all this here. So all those conditions has been met here. So only such data are such rules which confine to these particular constraints are displayed here. Okay, hope it is clear for you. Now we can do some pruning. Okay, so pruning is basically say if any data is not providing you enough knowledge, you can basically ignore that, or you could basically avoid that rule which comes in the in your output. So if you find any redundant data or if you find any unuseful data, you could basically remove it. Okay, so that is what actually you could see here. So in the above result, the rule 2, you could see this rule 2. So we are taking this rule 2. This is the rule 2. Okay, rule 2 provides us no extra knowledge in addition to rule 1. So it's almost like, like class is equal to second, age is equal to child. Here also they have just added a sex male, that's all the other information is almost the same. So since rule 1 tells us all about the second class, right? The children survived, everything it is already given in the rule 1. Okay, generally speaking, when a rule such as rule 2, so this is the rule 2, is the super rule of another rule. So it's like, it's completely related. So it's kind of, two rules are there which are actually kind of redundant rules. So what we could do is we could actually remove them. Okay, how can we do that? Okay, so that is what we are going to do here. So for doing that, so basically we are going to create a submatrix, okay, a subset of matrix. Okay, so we are going to create a subset matrix which is sorted. So that is what we are going to do. So there is a what is that function which is called is.subset. So if you could find a rule which is is.subset, then you could do that. Okay, and you are making all the other ones as it's a warning message, that's okay, and hopefully it should work. And then you have redundant dot column, so you are just then you're going to print, okay, which all ones are redundant. So when you see in this which redundant, you could see that it has displayed all the redundant. So it's kind of all the superset, the subsets of all those, it has been displayed here. So you could see here. So all these rules which we have got here, all those are redundant. Okay, from there it's actually a subset of all those. Okay, so all these rules are redundant rules, so they does not add any particular value to the rules, to the set of the rules which has been displayed. Now we will see how to plot these. So when we try to use this particular library, okay, so what happens is that, okay, this library is not there. So we need arules visualization. So we are just going to install the package arules visualization. Hopefully they are installed properly. So probably sometimes it takes a lot of time, because you are actually trying to take all the packages in that. Then you are doing a plot. So plot dot rules, okay, and okay, so plot dot, it was not over. Okay, so plot dot rules, so error in plot dot rules, needed a rules not installed or updated. Okay, so let's try running it once again. So now it should be fine. To reduce our plotting, okay. Jitter, use jitter is equal to 0. So okay, fine. So a plot is basically we get some particular plot here, and then we are plotting as graph, trying to plot it as a graph. So you could see here we are actually plotting it as a graph. And now if you want to plot it as a, yeah, so this is also, so the parallel coordinates, okay, so that is also possible. So you can have different type of so you have taken all these parameters and you have plotted. So all these things of visualizations are possible here. Okay, so this is all about a priori algorithm. So in a priori algorithm, you should understand in R there is a you have the function called a priori itself, which could be used, and that comes under the package arules. Okay, here arules, and for visualization you have something called arules vis. Okay, so this is what you have to understand. So these are the three packages which you have to understand when you learn about a priori by using the R Studio. Okay.